right. Nice to meet you guys. I'm John. I'm from the United States in Colorado. I've been a data engineer for about 7 years now, and just have recently been trying to learn about AI and sort of keep myself relevant, make sure I understand what's going on. And tonight's presentation is going to be a little mixture of AI and then incorporating that with data warehousing and dashboarding and sort of deriving insights. So I drew this diagram just so that I could give like a high-level overview of what I'm going to be doing. So I'm actually going to go through a live workbook where we're going to ask questions about the data in my database. And then the LLM model is actually going to generate SQL queries and the back-end logic that builds and creates dashboards in Metabase. So the idea here is, at the highest level, ask questions and then get answers about your data or build dashboards and create insights without ever even looking at your data. And one of the other concepts here, and like the reason that I'm looking into and building it this way, where it's self-hosted and not using an API endpoint, is because if you're trying to hook this thing up to your company's database, full of PII data or documents in your Google Drive, you probably don't want to be sending that information to ChatGPT or whatever service is out there. So the idea is to have and maintain full ownership of the entire process so you know where your data is going. In the workbook itself that we're going to be going through, I am using the API endpoint, but I will explain how it works. So we'll start at the beginning. So I really like Kubernetes for deploying these LLM models. Kubernetes is basically a really fancy task orchestrator for Docker images. You can run a lot of these open source LLM models on Docker images. And Kubernetes basically gives you the opportunity to scale really effectively. So if you need to make 10 images, you need to make 10 chatbot endpoints and scale out, Kubernetes is going to do that really well. So that's kind of how I have these things set up. And then I'm going to talk about Llama 2. So this is Facebook's open source LLM model. It's the one that everyone at the company just decided that we should have it. And then there's another open source tool called Llama Index. It is not affiliated with Facebook, but it's another open source project. And basically what that does is it acts as this intermediary point between the questions you're asking your data, which could be a database or it could be any type of file or document system. And it indexes that information so that it can actually send it alongside other prompts with requests to the LLM model to then get insights back. And the idea is, let's say that you are building a chatbot, right? But if you go to ChatGPT, it only knows X, Y, and Z about Latvia, right? But you want it to work really well for answering questions about where to go and what to eat. So what you do, and you use something like Llama Index, or you build it yourself, that gives the opportunity for the LLM model to answer the question if it thinks that you have good data that answers the question better than what it already knows. So that's what's happening here. And when I go through the workbook, I'm asking very specific questions. So it's never not going to use the database because it's just like, it's very, very specific. It should make sense when I get in there. And there's a couple other things that facilitate this working. So Another thing that I want to highlight and talk about is metadata. So that's kind of why DBT is there, and I will explain what's going on with that. But basically, this stuff is not just magic. Like, you cannot just hook up, you're not going to just create an engine with Llama Index on your database and all of a sudden it's super smart. It has to be able to understand what your data actually is, like comments about columns and data lineage and things of that nature are what make it actually be able to answer these questions really well. In this example, I'm storing data in a Snowflake database. I just like Snowflake. And then Metabase here is an open source software for dashboards. So this is an example of a chart that was generated by this process. I will say that I don't have very sophisticated data in there. I'm just kind of messing around. So we're not learning anything super cool here other than how to actually make this work. So talk a little bit about Llama Index, and then DBT and Pydantic, and that should cover kind of how all of this stuff connects. So Llama Index, it is it's an open source Python library that you can install, and basically there's a variety of different modules and methods that you use if you're going to connect to different data sources. So there's definitely a little bit of work involved in if you're going to actually like set up all of these and feed it into the engine. But it's going to take all of the documents that it has access to and index them. And I'll talk a little bit about that here. So there's really two main stages to what Llama Index is going to be doing. And so first, it indexes everything that it has knowledge of, so that that can be actually understood by an LLM model. And then the querying stage. So the querying stage is when it gets that knowledge back and then turns that into queries against your own database. There's another library that plays a kind of big role in this whole thing. It's called Pydantic. So Pydantic is basically, it's like, did I get back what I asked for? So I asked ChatGPT, I said, respond to me with a dictionary, and I want that dictionary to have these keys. Pydantic will tell you if that's true. So this entire process goes kind of back and forth between Llama Index and an LLM model, Pydantic, and then Python logic. That concept itself is called retrieval augmented generation, and that's what is going on in a lot of these LLM applications behind the scenes. You're not just going there and asking it to do everything for you. You're breaking it into chunks that you're confident it can do. And then for the system, you're linking it together to create a full stack application. So I'm going to talk about DBT just a little bit here. So DBT is used for making internal data warehouse transformations. That's one of my favorite tools out there. But basically what it does is it manages the building of all of your tables and databases and schemas in your data warehouse. And it has additional capacity and features for storing metadata about how your database works. And so this quote here is from a research paper that came out within the last year or two that's basically saying, hey, we tested this, and when there's a metadata layer that was created by DBT in this example on top of the database, these LLM models are like 35% more accurate at understanding what's going on. So the metadata piece is really critical to this system actually being able to understand your data and derive insights. So I have an example here of what a DBT file will, oh, that's kind of hard for you guys to see. But that's okay. I think, can you guys see this?
Yes.
Okay. So basically, this is a file that is creating descriptions. It's talking about primary keys and foreign keys. And then every time DBT builds tables in the database, it stores this information as metadata. And it just creates a really easy way for you to create that semantic layer. And then that semantic layer is used to enhance the way that Llama Index can index the information, and so that the LLM model can understand what your data actually means. So here at the top, we're just importing a couple of standard libraries, Snowflake and LangChain, Pydantic, which I talked about. We're going to go down through this a little bit. Okay, so create engine. So this is going to essentially create an engine that links Snowflake, connects Snowflake and Llama Index. And then I'm going to just run a sample query using that engine. So select subject from Hawaiian Legends. And I was thinking about explaining to you guys what the data actually is so that this can make sense. But I figure we might just ask it, because I'm lazy. Okay. So this is a little script that I wrote just to link all of this together. And what it does is it goes to Snowflake and queries all of the metadata I was just talking about that was generated by DBT. And then every time a question is asked to Llama Index, this information is sent with it. So I just aggregated all of the descriptions of tables, descriptions of columns, primary keys, foreign keys. And that's super important because you want it to be able to join tables. Otherwise, it's really not going to be able to do much at all. So the better metadata you have, the better this thing will work. Okay. So another thing I'm going to talk about throughout this is prompts. So prompting is so, before I even did this project, didn't realize how critical it is. But I have this variable right there called add additional context. So as I was going through and building this, I noticed that it would write a lot of subqueries, and I hate subqueries so much that I was like, hey, stop doing that. If you're going to join tables together, please use CTEs. But it's kind of interesting what happened is because it just starts overthinking everything. All of a sudden, it was trying to join every single table together and use a CTE in every use case, even when it wasn't necessary. And that's why I added this one down here. And I was like, hey, stop that. Only include them if we really need it. But it didn't work. So it's a really delicate process of figuring out what prompts actually make it understand your data better and make it make better decisions. All right, cool. So we're just going to ask it a question, see what it says. So I'm going to say, can you explain what this data is? What's the data? Okay, so we're going to ask it, can you explain what the data in this database is about? And we will see what it says. It's taking a while. This one took 18 seconds. Okay. Yeah, I just tested this right before I got up here. It just doesn't like this question. Okay, well, while that's loading, I'm just going to show you an example output from a question that I've asked it previously. And I will, okay, thank you. What's it about? The database contains data about various books related to Hawaiian legends of folklore. Some of the books in the database include Foreigner, so there's a bunch of books. It's about a bunch of legends. So really, that wasn't the best answer ever, but it was an answer. And then it just select everything. Okay. So it's a database that has information about books, so actual text from books from Hawaii. And then there's a handful of other schemas that contain metadata about information on what's in those books. So I can ask some kind of question like, in what places do Hawaiian legends occur the most? Hopefully this doesn't take another 50 seconds, but, oh, it's because it selected everything from the table. There we go. Okay, what I'm going to do is just go through and run some stuff.
John, can you make larger font?
Oh, yeah. How's this? Yeah, we'll have to do a little. Okay, so, in what places do Hawaiian legends occur the most? And it comes back with, it basically gives a couple answers. Like, it uses natural language from results of the query to explain the answer, and then it sends you the query that it used to derive that information. So that's the query that it used, like subject, count, group by the subject. And then while these next couple load, I'm going to show this. So get into Pydantic just a little bit. So Pydantic, I'm saying from Pydantic, import base model. And basically, I'm saying for this question I'm about to ask, like, if it's not a dictionary that contains a list of strings, I don't want it. And it's super important because the result from that question is used to send back again and back and back. And so what this section of it is doing is that first one was, hey, ask a question about my database, get a query back. These next couple of steps are take that query and say, go back to an LLM model and say, what kind of data do you think this is? What kind of visualization do you think makes sense for it? What do you think the name of the dashboard should be? What do you think the X and Y axis should be? And it's these steps that Pydantic is super important because the results of those are used to generate JSON configuration that is posted to the Metabase API. So it won't work. If it's not right, it won't work. And you'd rather just retry, get a new answer, than go on to the next step and fail there. Last time I did this, I got tired of coming up with questions myself. So I just started asking it to ask its own questions. So it's just going to read all the metadata, run some queries, and come up with questions that you can even ask about the data. And then I took those questions and fed it back to it. So make it come up with the questions, send the questions back to it, get queries, and then build dashboards. And I don't know for certain, but I have a feeling that that concept is what's going on in some of these real tools that do similar things to this behind the scenes. Okay, so this next part is going to be another piece on just why prompts are so important. So okay, so yeah, I just came up with all of these questions. Okay, I'm not going to go through every extractor template because they're pretty similar, but I will go through this one. I'm saying, hey, you're a business intelligence analyst. I need you to determine a classification for this query. That's your job. And I need you to determine, is it a table? Is it a numeric indicator? Bar chart? Line chart? And then right here is where I'm saying, I need a JSON back, and I need that JSON to have these keys. So run some of that stuff. And then it moves on to the next step. And the next step is from that previous step, which told us, is it a bar chart or a line chart? We go back and we say, hey, I've got a query and it's a line chart. Now, can you come up with all of these visualization settings? And then this is an example of just a super simple, oh gosh, super simple JSON that is actually fed to the Metabase API. So just for your guys' reference, this is what Metabase looks like. I'm self-hosting this in Kubernetes, and so I have access to the network requests that happen. And so when you do that, you can sort of reverse engineer how these charts are actually built. And that's what every one of those steps from Pydantic was doing, was trying to understand what kind of chart it should be, but also getting it in the right format to actually send to the Metabase API. Okay. So this is an example of pretty close to one of the last steps of this whole system. There's different functions for each kind of chart that's recommended. And so this is kind of what I was getting at when I was talking about retrieval augmented generation, which is that the Metabase API is the Metabase API. As long as I don't change the version, it's going to stay the same. We don't need to ask ChatGPT how that works every time. We needed to understand things that require analytical or complex thinking. But the stuff that doesn't change, you just code that and then bring all the pieces together. So this function aggregates all that information from above and submits that to the Metabase API. So in this example, I'm just asking it to build a question, but towards the bottom, it's a bit more fun and just going to do the whole thing. So here I'm saying create dashboard. So there's dashboards, there's collections, and the way that this is set up is that you can ask it a bunch of different questions, and then it will make multiple different visualizations and kind of group all those into one dashboard. Yeah, let's see what this says. So we asked it a question. I don't know what we asked it. Okay, there we go. Collection 37. So it just made us a collection and a dashboard. A collection is just like a folder. And then this is my loop asking it to ask questions and then feeding those into it. But we don't want to wait here all day. I'm sure you guys have somewhere to be. So we're going to ask it to ask less questions. Okay. Cool. So then the last thing that I have is, it's just going to pop that off here in this notebook, but we could also go into Metabase and look at the output. And so I'll just show you guys some examples of some thrilling insights that were created by this process. So yeah, nothing special to look at, but I hope that you guys can see what I'm talking about here. If this was in like a real production database and you had real data, you could probably answer some cool questions. And I think that it would require a lot of work. I don't think it's just this magic box that's just going to tell you everything you want to know. But I think that if you work with it and you tweak it, that you can actually start to uncover and answer things about your data that would take too much time for everyone to go through themselves. Let's see where this is at. Okay, I think it's almost done. Cool. So this is going to build the dashboard. We can check it out, but that's pretty much all that I had. Does anybody have any questions on this? Kind of pop back at this so you can take a look at it again, but cool.
So, any questions?
How does this work against like real-time data analytics? Like if you had an analyst performing some functions and you had a team of analysts doing this like day in, day out,
Yep.
can you replace like real-time data analytics with a similar process? Like the data set, can it be like coming in by the millions per minute and you can analyze it?
Yeah, I'm pretty sure that you could, right? Because I think you'd send it straight in there. So if we look back at this Llama Index, it's indexing and organizing all of the information that you're sending to it before it asks the question. And so in an example where you have a stream of data coming into this, it could also be connected to your database. So those would then just be 2 points of information that it's indexing and sending to ask questions or derive insights. I think as far as like real time goes though, like there's going to be a little bit of a lag. You can't just like hit it a million times. Like it's not going to come back immediately, right? But it can definitely tell you information about incoming data. Does that make sense?
Yeah. Can it be fingerprinted at all? Like can you create some sort of like pattern hash functions or something perhaps that would check for like, I'm just thinking from like a detection system perspective, like an IDS or.
For sure. I'd have to imagine it's possible, but I don't really know enough about about what that process would look like to confidently answer that. But to me, like logically, if you have, so here's what I think would make it work, right? So you have information and data about what a threat looks like, right? and you probably store that somewhere, or you have some knowledge base of things that you look out for. And so you could, every time, you could stream information in there and have it make requests to the database and the stream of incoming activity, just like perpetually, asking, what does this look like? What does this look like? But every time you do that, you're sending information and context about what a threat might be or what it look. You know what I mean? Like you're teaching it, or you're giving it information that will make it better at predicting what that data is. If that makes sense.
Hi. Excuse me, I guess I'm gonna have a little off top here, but I had to ask, why is your whole presentation is done in Adobe Illustrator? Thank you.
I just like it. I don't know. It's I make diagrams all day, and you just can't. I don't know. There's no other tools that are as customizable as this one is, in my opinion.
Not an ordinary stuff you'd see every day.
I don't think this is normal anywhere, but I like it.
Thank you.
Yeah.
Good question here. First of all, props also for the presentation in Adobe Illustrator. That's quite the Sigma move.
Thank you.
I was just wondering, for example, as someone to whom English isn't the native language, I was just wondering how this AI system deals with grammatically incorrect questions, like how well does it behave?
Gotcha. Yeah. I know that different models have different levels of like their ability to understand language. So I don't know if you've ever looked at or seen that people run like performance metrics on a lot of these different models. And so in this example, I was talking about like Llama 2, which is from Facebook, but there's hundreds out there. And different ones are better at certain categories, and some of them are better at natural language and understanding it. And so I think some are going to do really well at grammatical errors, and some might not perform at all. And they also support lots of languages, and I think it's growing over time. So I would say that I think it's pretty good, but like if you're as bad at spelling as me, it might have a hard time understanding, because sometimes spell check doesn't even know what I'm trying to spell. But yeah, I think that they're pretty good.
Any more questions? Try to find. Oh.
I'll just have one. As you were talking about the Facebook's Llama,
Yep.
Considering it's an open source tool, I was using just an OpenAI tools in this case, connected with Llama Index. Does it allow you somehow to control this data? I'm again with the security questions here, but
Yeah.
what's the point of using this open source tool exactly? Models, I mean.
Yeah. So using the open source model, you always have the vulnerability of like, is there something in that, right? So disregarding that point, like if you were to have a team that goes through and validates the actual application itself, the idea is that that it's inside your own infrastructure. So let's say you've vetted the software, you've gone through and make sure it doesn't have like any security leaks in it. Well, now you're running that in your own system. So you're running that in your own private network in AWS, and let's take out the Snowflake piece. Let's say you do this on a Postgres database that's inside your AWS account. The idea is that you're not sending data or granting access to your database to any external providers.
The practical question, how much of money it costs to you to host this Llama model right now?
Yeah, so it's like obviously I don't run it all the time. It's not as expensive as you would think. I have, second.
It meant to be a simple question, actually,
Yeah,
so you don't
okay.
need to go
Anyway,
very deep into it. Thank
It's
you.
like $5 an hour on an EC, yeah. Something like that.
Decent. Thank you.
So, any more questions?
Is the dashboard ready?
I sure hope so. Look at that. No, that's not it. It's a video. Oh, it's still running. I'm sorry. I don't make the rules. Cool. Thank you, guys.